Now we move into TCP/IP port numbers. This is Module 6, and I'm Joe Wilson with RouterFreak.com. And today we're going to discuss what are ports in relation to TCP/IP and IP addresses and TCP and UDP applications. We'll then go into looking at some well-known ports and then how the communication occurs between devices when they're using port numbers. So, TCP/IP port numbers, they operate at layer 4. You know, we're moving up in the OSI model, and we're moving up into the stack. If you remember last time, we went into how layer 2 and layer 3 addresses, MAC addresses, and IP addresses relate to each other. And today we're going to move up in the OSI model, up in the OSI layers to layer 4, and we're going to be discussing TCP/IP port numbers. So to give you an idea of port numbers, I think the best way is to look at, say, a web server. So on our little network that we have here, say this was a web server. And if you know, web servers are HTTP, right? And web servers listen on what's known as port 80. So if you were to go to this, if you had a web server running on this server over here, 197.1.1.5 port 80 you would see that there's a web server. That's where the web server is listening. So when my computer, or any computer, opens up a browser and wants to get to this web server, what they do is they open up the browser and they go to that IP address. They go to they want a destination IP address and destination port of port 80. So essentially what's going on is every server has multiple different services that run on the server. For a web server, you can have, well, really on most any server, you could have a web server that's running on port 80, that's your HTTP server. You could have a DNS server. You could have a mail server. You can also have, say, maybe a Microsoft Active Directory server. And each one of these servers, they listen on the same IP address, but they all listen on different port numbers. And each port number represents the service that is the well-known service that is running on that server. So for web services, on my computer, what I'll do is I open up my browser and I'm going to go to I'll go to a website, and that website happens to be 197.1.1.5, for example. Well, what my computer is going to do, he's going to go to the destination port, that IP address of port 80. Now when this server gets this request, he's also going to see that that request came from a particular source port. So the source port, if you ever notice on any desktop computer, that you'll make these connections to servers or services, and they're going to come from a very high numbered port. Probably, I don't know, I'll just say 65,000 will be the source port. These ports are known as dynamic ports, and really they're any port that's above 1023 could be considered a dynamic port, or a non-well-known port. Now there are reserved port numbers, and we'll get into some of that. But essentially, when my computer or your computer opens up a connection to a web server, it establishes what's known as a socket. And the socket is the source port to the destination port, creates the socket or the session, the TCP/IP session. So when a browser opens up a session or connection to a web server on port 80, that web server gets it and knows where to send it back to. They'll send it back to the source IP and the source port number. Now, to give you an example, here, let's pull up a command prompt real quick. Let me see what I have here. Let's see. If you do, you can do this on yours too, but if you just go to, if we just bring up a command prompt, and you can do this too on your computer. If you go to Start Run and just type CMD or type command, it'll pull up your command prompt. And what we want to do, what we can do is we can type in netstat -F, and this will show you all the ports, the source ports to the destination ports. Now let me do this again. Let me do a netstat -N. That's a little bit better. So what's going on is, here you notice, remember back in TCPIP where we said that the loopback address was the 127.0.0.1. Well, so here you see I have some loopback, the loopback IP address and the loopback source port going to my loopback and another destination port. Well, a lot of times what your computer will do, it'll make these connections to itself. Services will make connections to themselves as they operate, as they go through their business. But what we can also see is, here's my local IP address, 192.168.1.109. That's my local IP address on my local network. Now let me bring up a browser real quick. Let me see if I have a browser. Okay, so here's a browser, and I wanted to bring this up anyway because I wanted to talk about these port numbers. And if you go to IANA.org and you do a search for port numbers, IANA is the Internet Association of Numbering. Oh, I'm probably getting that wrong. Well, here, let me just remove that. Internet Assigned Number Authority. Thank you. If I can remember all these acronyms, I think my brain would explode sometimes. But if you just do a Google on well-known port numbers and go to IANA.org, and I'll put this link in the sidebar so that you'll have it. But if you scroll down, you'll see there's a bunch of well-known port numbers, and all these ports are port numbers, TCP and UDP port numbers that are reserved and assigned by IANA for commonly known applications. Like if we scroll down here and we see here's FTP, File Transfer Protocol, and it's on port 21, TCP and UDP. SSH, Telnet, port 23. SMTP, which is mail, Simple Mail Transfer Protocol. And we keep going down, and if we look for port 80, here we go, port 80, TCP, port 80, www, HTTP, www, or www-HTTP. These are the names that the web servers are commonly known as, and it's port 80 TCP and port 80 UDP. Now, web servers don't use, at least today they don't use port 80 UDP. But what they've done is they've reserved port 80 UDP for web servers to use. Now, you know, in the future there may become some application where we can use UDP. And what is UDP? UDP is a unreliable protocol, whereas TCP is reliable. So right now we want to use TCP a lot because it's more reliable than UDP. Now there may come an application where you might want to use UDP for web services, but for now primarily TCP is what we use for web servers. So now if we go back, let me go back to our slides. Where was I? There we go. So if we look at our command prompt, we can see where, let's see, let me do this again. I can do a -F. -F will actually resolve the names. So here you can see this is where I open the browser. I open the browser to IANA.org, HTTP. It's established. Here's my source IP address, and here's my source port number. Notice it's a high port number. It's 54871. These are the sessions, and what happened is when I opened the browser, I just made one request to IANA.org, but because there are images and other web objects on that page, what will happen is the browser will open up multiple connections to the web server to pull those down to kind of speed up the transfer of the page, so everything loads much quicker. So that's kind of how you can do it, and I encourage you to do this on your computer. You know, you do it right now. You do a start run command and type in netstat -f, and -f will actually resolve. It'll try and resolve the destination name, the destination IP address to a name, or you can just do -n, and that'll just give you it'll just give you the source IP and port to the destination IP and port, and then you have some different TCP states here. There's an established state where it's actually the session is open. Here's where I opened up an HTTP session, but haven't done anything for a while. So then the TCP stack will start to close it. It'll start to close out that port. If there's no activity, it'll close that session down eventually. So that's basically how you can see what your source and destination ports are. So as we go back to our diagram, you can tell that, again, here's where the source port is and the destination port. This is where this destination port allows the web server to know not only it needs to go back to this particular IP address and port, but it also allows the computer to know which browser window opened up this web connection, if you can kind of get that. So again, here's a list of port numbers, and I just took a little snippet out of that port number list that IANA shows us when you go to their site. And the thing I wanted to really show you again, let me bring that up again. Where is it? Okay. If you notice, we have all kinds of ports here. If I just scroll down, look at all this stuff. There's just about every port that you can, every kind of look, here's some Cisco ports, NetBIOS, SQL, here's some SQL ports, SQLnet. You just keep scrolling and scrolling and scrolling. It's just incredible. This is basically a port. Now there are a total of 65,535 possible ports that you can have per IP address. Now that's a lot of services that you could be running at one time. But I want to just keep scrolling down here, and I just want to show you something here. If I keep going and going and going and going and going and going and going, eventually we'll get to a point. Let's see if I grab this. Where was it? Okay, there it was. Real quick. Notice how we get to 1023. That's the end of what's known as well-known port numbers, and these are reserved by IANA as well-known ports. After that, anything above that becomes registered port numbers, and this is where you have application developers will go to IANA and ask, hey, I want this port to be reserved for my particular application. So here you have Blackjack. There's another really cool port. It's interesting because if you're a gaming fan, a lot of games will be out here as reserving a port for their game. Let me see where it is. It's in the 3000s, I think. Just to give you an example. Where is it? La la la. Galaxy server. Oh, I forget what port it is. But as you can tell, there's just an unbelievable amount of ports out here. I should have pulled this up ahead of time so I could could show you. But basically, I mean, there's Tick Port. I mean, there is NetWatcher. That's a firewall. Ironmail. So anytime a manufacturer creates an application or something that needs a particular port, they'll go to IANA and have it dedicated, or try to ask for it to be reserved just for their processes, just for their servers or services, whatever product they've created, that may need it. Okay, so here's what I was looking for that I really wanted to show you. Check this out. Look at this, World of Warcraft. I like World of Warcraft. I'm a fan of it. But what's more impressive is that this game has went out and has reserved TCP and UDP 3724 just for their game. So now anytime any player who wants to play that game gets on their computer, they'll fire up their game and it'll use 3724 to go back and forth for the game to operate. So that's why it's really important to understand how this functions. Now, there's some well-known ports that I really encourage you to not necessarily memorize, but definitely get to know better. And some of them you probably already do know. That should be 80. If I can fix that. 1 second. Okay, there we go. I fixed it. So HTTP is port 80 that we know. It's also allowed 8080. Now secure HTTP, which is HTTPS, is 443, port 443. Another one that's really common that you may want to know is DNS. DNS uses, but if you notice here with DNS not only uses TCP port 53, it also uses UDP port 53. So the main difference here is the server primarily uses TCP port 53 to do zone file transfers and things like that with DNS, their DNS files, domain name files, right? Clients, whereas your browser, or anytime you go out to the web and you want to look up a name, your browser looks up a name to find an IP address, it'll use UDP 53. And it does that because we want to make that experience as fast as possible, right? So we do a UDP DNS request to resolve the name as fast as we can in order to pull back that web page. Then we have POP, and POP and SMTP are similar. POP is Post Office Protocol. SMTP is Simple Mail Transfer Protocol. Both of these are email-related applications that allow you to get your mail. Telnet, port 23, you should know this. Port 23 is Telnet. And SSH is a secure version of Telnet, or secure shell. Telnet shell, secure shell. Secure version of Telnet is port 22. Then we also have FTP, which is commonly on 20 and 21. Some of our UDP ports, I pulled some of these. Some of these you don't necessarily need to know by heart. SMB is server message blocks. This is a Microsoft file port where when you transfer files between clients and servers on a Microsoft network, they'll use SMB port 445, UDP port 445, which is SMB. Syslog uses 512. NTP, which is Network Time Protocol, uses 123. Another one, TFTP, and you're going to get familiar with this a lot when you're doing when you do iOS upgrades on a router or a switch. You're going to do that, or configuration changes, or you save a configuration. You'll save it on a TFTP server, and that is UDP 69. So that's a good one to use, a good one to memorize. So again, well-known ports are ports 0 through 1023. Ports range anywhere from 0 through 65,535. So I guess you could really have a total of 65,536 ports that you can use. So that's it. That's about it. Kind of short, kind of sweet. I hope you were able to understand what we were trying to. What does my wife say? Are you picking up what I'm laying down, or can you smell what I got cooking, or what does that say? So today we went over TCP/IP ports, or understanding what port numbers are, and they're basically an extension of the IP address that allows local services to communicate with other services that are local to another destination IP address. So we have source ports, just like we have source IP addresses, and then we have destination ports, just like we have destination IP addresses. Ports, what are ports? Well, they're, like I just said, they're used for services. They can range anywhere from 0 to 65535. And again, some common port numbers are HTTP, FTP, Telnet. And if I were to just throw those out, you should be thinking in your head, HTTP is port what? Port 80. Telnet is port 23. SSH is port 22. FTP port 21. That kind of thing. See, and if we go back to our list, so Telnet 23, SSH 22, FTP is 20 and 21. A lot of times you can just say 21. The data port is running on 20, but the FTP does have 20 and 21. And so again, there's that list. And that's about it for this module. If you have any questions, again, I encourage you to go out to the forums. Put your questions out there. I'll be happy to answer anything you have and try and clarify if it's not clear enough. I'll put links in the on the this module's page for links to IANA, so you can pull that list of port numbers up for yourself. And again, encourage you to do a start run command, and that command again is netstat, NETSTAT, and then you want to follow that with a -F, or you can do it with a -N. Make an N. My handwriting is horrible, but anyway, I hope this was great for you, and we'll see you next time. Again, this is Joe Wilson with RouterFreak.com, and we'll talk to you later. Bye-bye.